Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
The new space industry requires a highly trained workforce in multiple specific disciplines. Getting the training companies need economically can be a challenge, both in time and financial cost. My guest on this edition of the Ex Terra Podcast is Joe Horvath, CEO of Nova Space, a company focused on providing online training for the new space industry. And Joe, thanks for joining me today.
Thanks for having me. It's a pleasure to be here.
Let's talk first of all about New Space offering professional development for the space industry. How do you go about that?
Well, for Nova Space, we're taking a kind of a unique approach to professional development and training. When you look at some of the other industries out there, all of our courses and professional development opportunities are all online, digital, asynchronous courses. We don't do video lectures. We don't do click-through PowerPoint slides. All of our courses are designed to be interactive, where you're actually practicing the behaviors that you're going to be doing on the job with regards to all kinds of different specialties within the space industry. And so we've designed it with an industry leader in e-learning development, with the goal of training people to be competent and confident in their knowledge and their ability to use that knowledge in tackling the problems that they're going to face on the job within space.
Can you give me some examples of what some of those specifically might be? You said there are specific things that you follow through on the courses. So what kinds of things will somebody who takes one of your courses expect to find when they get online?
Yeah, great question. So right now, we've been focused on fundamentals. And by that, I mean the fundamental knowledge base areas that are required to be competent in any kind of space job. And the reason we started with that is that is the language that everyone shares that enables communication, both within teams, external to teams, understanding user and stakeholder requirements. All of that requires just a foundational understanding of the basics of how we use space in large part. So our courses start by focusing on things like the space environment and electromagnetic spectrum theory, orbital mechanics, space communications or SATCOM. We look at things like remote sensing, position, navigation, and timing, really all the fundamental areas that impact how we use space. And we do that by not only focusing on those fundamentals, but then applying them in real world challenges such that people within the space industry are trying to accomplish. So some of the challenges they go through are designing an electro-optical satellite designed to, in the case of the course that we've designed, in determining moisture content of soil for soybean growth is the challenge that they're given. And they work through developing all the aspects of the satellite, the sensors, the launch, everything. And in doing so, they get to understand how all those various parts of designing, launching, and operating a satellite work together, what those trade spaces are, how they will interact based on their position within a team, whether they're a leader of a team or they're supporting a team. Our goal is so that when they walk into whichever aspect of the business that they're going to be in, they understand what those needs, requirements, and challenges that their partners are facing, so that they can communicate and support each other. And we find that is by going through challenges like that, it's so much more effective than just clicking through slides and answering some questions.
When you have a company come to you for professional training, are the people who are signed up for the training generally already scientists? I mean, you can't expect somebody like me to walk into a class on orbital mechanics and have any understanding of it whatsoever.
Right. Well, I mean, the reality is that there's such a wide spectrum in all of these topics, from, basic to, PhD advanced research kind of level of knowledge. And the surprising part is getting that first part of just the fundamental understanding really doesn't take as much as people think. And that's a real barrier that a lot of people think regards to being able to enter the space industry or work in the space industry. They think about rocket science. They think about astrophysics. They think about these things that, and I am those, and they are complicated, but it doesn't have to be complicated. So for instance, when we teach orbital mechanics, our focus isn't on the math specifically of, designing really complicated, cislunar orbits. No, what we're focused on is the understanding of there's 4 to 5 major orbits that are used. These are why we use them. This is how we define them. And this is the benefits or drawbacks to using those, so that when somebody who is an expert is talking about some of those aspects, they understand. They go, oh, okay, I understand. We're going to do it in low Earth orbit because that means the sensors that we're using will be able to do this. We can't do that in geosynchronous orbit. It's the fundamental level stuff. Now, you could take that, like you said, or alluded to very advanced levels. And that is the next step for us, is to go into those advanced levels of it. But I think establishing that foundational knowledge across the industry that's lacking right now is one of the things that we're really focused on doing, because there is no standard. When you look at like cyber or the internet and how that kind of developed through the late 80s and the 90s, early on, it was kind of the Wild West, right? Everybody had their own protocols. Everybody had their own methods of doing things. And then it started in the late 90s to become very standardized. You had Microsoft and Cisco and different companies coming up with very standard protocols, very standard ways of describing things and language and communication. And that is what really enabled it to become not only an industry that is sustainable and allows others to grow off of those things, but it also provides career paths then, because there's a standard that exists. And that's one of the things that we're really focused on is developing that standard that people can then grow from. And it's good because not only does the employee or the learner know what they're expected to know, but the employer understands what they're getting as well. And that works well on both sides.
I can almost see a side market for you offering basic courses to people like me who are involved in the industry. As a journalist, I try to be knowledgeable about the topic that I'm talking about. And sometimes a lot of this stuff can be difficult to grasp. So I'll just throw that out there for you as a kernel for a marketing plan in case you want to look at that.
What you hit on something is wonderful, is that, as the space industry grows, especially now that we're really talking about a commercial space industry and not just a government focused industry, there are so many companies out there, and they need to hire not just scientists and engineers. And we could talk about what's lacking with them as well, but they need human resources people. They need, financial, law, project managers, all kinds of types of people. My son is interested in graphic design, for instance. Mm-hmm. Well, you know what? SpaceX needs graphic designers that are going to go out and create beautiful infographics and things that are going to help sell, right? All of those types of things that any company needs, all of these space companies require. And so for so many of those positions, they don't have to be experts in space, but they need to know enough to understand how to communicate, how to take what those scientists and engineers are working on and communicate that to the general public or to customers or things like that. And that's where, so as a journalist, as an example, right? If you're interested in being a journalist in the space industry, you have to understand the fundamentals. Sure. You don't have to be an expert. And that's one of the areas that our courses are designed to raise that standard bar across the spectrum for all those different types of jobs, positions.
I know I came out of the aviation industry as well, and there were times, every business has its own lexicon, and to be able to talk knowledgeably with people and have them take you seriously, you need to be able to speak their language. And I think that's what you're getting at.
Yes, absolutely. And then from there, that's where the professional development comes in, right? It's a career path. So right. Yes, there's that standard foundation, but then you need to keep growing and changing as that industry grows and changes. You need to keep current. You look at something like project management as an example, right? PMI has developed the Project Management Institute has a very defined set of career paths and different certifications and things like that. That's what happens with any mature profession or industries. You get certifications and licenses and very defined career paths that exist. Nothing like that exists for the space industry at this point.
So do you plan to offer professional certifications?
Yeah, I think that is definitely a direction we're going. Right now, we're focused on what we call credentials. And so all of our courses come with a digital credential through a partner company called Credly. And they've been around for a number of years. In fact, some of you may have seen in the news, they were recently acquired by Pearson VUE. And Credly is wonderful because they are these digital credentials that verify that somebody has actually accomplished what they're claiming. So instead of just, anybody can PDF and take a certificate, right, and take that image and put it online or whatever. That it doesn't necessarily mean that much. Right. What's great about Credly is it's a digital credential. It's blockchain based. It's verifiable. And the cool thing about it is that companies can then go and search people who have accomplished these credentials. And, so as they're looking for new performers or new people to join their company, they can go look for people that have these skill sets and have demonstrated these skill sets as they're going out to search. And then it goes the other way. Those people who have accomplished those, they can utilize that with companies saying, hey, look, I have these credentials and you can verify that I've accomplished it. And you can even see all of the learning objectives and the things that I've demonstrated my ability to accomplish. So it supports both ends of the spectrum.
You kind of touched on this earlier, but I wanted to ask a little bit more specifically about the college graduates that you're seeing coming out. Do they have the right backgrounds to compete in this industry? And if not, where could they improve? Yeah,
it's a great question. And I'm coming at this from somebody who, I have my undergrad was in astrophysics. Mm-hmm. And then I have a master's degree in space operations. So I've done, space college level stuff. And what I'll say is, for like 90% of the jobs out in the space industry, you don't need advanced or even necessarily basic college level space education. And I think one of the things that falls apart here is that at colleges, they're very focused on education from a theoretical standpoint and from a research standpoint. I mean, that's how they work, right? Whereas in industry, when you talk about training, you're really focused on performance. You're focused on behaviors that you're going to bring to the job. You're focused on, accomplishment of tasks. And that practical sense of it is not necessarily the focus of what colleges do. So that's one aspect of it. Another aspect is that, I'll use a mechanical engineer as an example.
Sure.
Space companies need mechanical engineers 100% in developing systems and building things. A mechanical engineer that goes to college, unless they purposefully choose some very specific extra courses to give themselves some space background, they're going to have no space background coming out of college. And even if they do some space education in college, it's likely going to be stovepiped into like a very specific niche area that their professors are interested in. That's just the reality of how this works, right? And so maybe they got to experience something related to how satellites do their attitude determination or the optics used in sensors or something like that. But it doesn't mean that they understand the breadth of those other topics we talked about, like the space environment and orbital mechanics and launch and propulsion and that breadth of understanding. We've talked to some fairly senior people at NASA, and they explained to us that, historically, if you bring a mechanical or an electrical engineer into NASA, it would take them on the order of 7 to 10 years of just kind of on the job training until they just have that basic mastery of the foundations of all the aspects of space. In today's environment, that doesn't work. That right. Worked back when space was government focused, NASA, DoD, intelligence community, up through the 90s and into the 2000s. That worked. It was a very static niche.
And they went at NASA's pace.
Right. So a few people would retire, a few people would get brought in, but it was a relatively static workforce. Now with the explosion we're seeing of all these companies, there just aren't the people to go around. And you need to get them trained up and experienced much quicker than they did in the past.
What would be the value to skilled trades? I mean, I heard at one point that if you were a welder and you wanted a job, go to Boca Chica. Is there demand in that at that level as well?
It's a great question, because that is a whole nother part of this pie that is missing out. So we kind of talked about the college side, right? Like the engineers, the for or postgraduate level training in very specific areas. And don't get me wrong, if you want to be an astrodynamicist and design the actual flight path of space missions, yes, you need that level of the math and the physics and things, 100%. But we also need people within the space industry that are building this stuff, the technicians, the skilled labor that's doing, welding and electrical work, plumbing, HVAC, all of these type of things. And those people exist, but they don't even realize that they can go work for space companies. And they don't need a college degree in space, right? So if you're an amazing welder, you can be extreme value to a SpaceX or an Intuitive Machines or, Blue Origin, all these companies, they need welders as an example. The key is teaching that welder the basics of space so they understand the environment that they're welding for. So that welder, there might be methods that they use for welding on, terrestrial things. There's methods that they use for welding for aerospace applications in the atmosphere. Well, there's unique things that are needed for the space environment. So having them understand the basics of the space environment and what they're welding for, well, now those are going to be the people that come up with new ways of doing it, new techniques, better ways of doing it that are going to make you successful. And all it takes is a basic training level of understanding, okay, this is the uniqueness of what I'm welding for. And that applies across all the trades. Really, they're needed. Seamstresses are needed. Sure. I mean, you'd be surprised. It's extremely wide. And I think that's one of the challenges when we look at the space industry. So often when we look at statistics, they talk about what you would pull from, government workforce codes that exist for these different professions. But the problem is space is unique compared to the terrestrial environment, and there are no workforce at the government level. I've worked with Office of Science and Technology Policy and Department of Labor on some of this for some things. Nothing exists for defining what it means for those job roles. And that's going to be important for all these companies trying to do these amazing things with new technologies and capabilities. The people are what are going to support it.
I'm talking with Joe Horvath, CEO of Nova Space on the Ex Terra Podcast. Take a moment right now to click subscribe to make sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Ex Terra, the Journal of Space Commerce. Joe, this industry is growing and changing rapidly. What do you do as a training company to stay on top of the innovations and make sure that the training that you're offering matches what's going on in the industry?
Yeah, I think the most important thing is being involved with the major organizations that exist out there and being partners with them, and then specifically working with companies to get feedback on what they need and want. We at Nova Space, as an example, we're partnered very closely with the Space Foundation. We have their the Space Foundation certification for education. And we are also under the Keystone Space Collaborative. We are their education partner. And there's others as well. Those types of relationships are important because that way we're involved with those stakeholders to understand what their needs and desires are, what they're lacking and what they're needing. And then also we work very closely with our customers and organizations that are out there, both in business and academia side and government as well, to be honest, to make sure that we're developing courses that support their needs and goals. And then obviously the other side of it is just being a professional in the field. My entire team, we're constantly following the things like you are with news and, whether it's the SLS launch or the James Webb Space Telescope, or what's going on in new technologies that are coming online.
Let's go back to the education piece for just a moment for one more question. And I'm interested to know if you feel like there's enough interest in the STEM fields still to keep the pipeline of potential employees full. And So how can technical subjects like those that are necessary for what it is that we're doing be made attractive to kids who have spent their entire, unfortunately, seems like they've spent their entire lives on TikTok?
Right. Well, I think so. For one, there's some interesting statistics on that. And my co-founder, Christopher Allen, and I recently released a paper called Space Storm Rising about this very topic. The challenges that exist in this workforce development, but specifically in how do we get people into it? There's a recent statistic that 75% of STEM grads from college, only 75% go into a STEM career. And it's, what's going on there? What are we missing? And I think part of it is a lack of excitement about it, a lack of recognition that this is something that they can be successful in. I think part of it is making it applicable to their daily lives. I think too often space, we see it on the news or we hear about exciting things happening and we go, oh, that's really interesting. But we don't realize that those things that are happening are impacting us every day. So, if you're going to go explore somewhere, check out maybe a house. Let's say you're going to go buy a house today, or you're going to go visit a house that you're looking at buying. You're probably using GPS on your phone to get there coming from space. You're very likely looking at satellite imagery, maybe either on your phone or the computer of what things look like that came from a satellite. You use an ATM today. That's probably going off a small terminal on the roof of that gas station or that building that's connecting that. The stock market is using timing from GPS to correlate trades. Aside from the more magnificent things that are going on with regards to launching rockets or building hotels in space or mining on the moon, those are all amazing and exciting. But even understanding just the daily impact that space is having on people, I think there's a real lack of recognition within the public on that. And I think as people realize more and are educated on how it impacts their daily lives, it becomes more exciting to realize that I can have an impact on bringing new and more interesting things and capabilities to humanity itself.
Yeah, anybody who's ever used a Teflon skillet or an electric screwdriver or Velcro owes that to the space industry.
It's amazing, isn't it? I mean, it really, and I think that's only going to accelerate as we go forward. And we start doing more and more and more in space now. All those technologies are going to come down.
But people such as Elon Musk and then also Peter Zahn, who's a global strategist, have talked about a coming demographic collapse of 25 to 65 years over the next 25 years or so. So is the space industry going to have enough people and, more importantly, train people to accomplish the industry's goals, do you think?
On the current path, no, it's not. It really isn't. Like I talked about, traditionally, it was a very niche, stable, static workforce that supported NASA and government satellite development. And there was a little bit of commercial, right? There was a little bit of SATCOM out there, and there was a little bit of, your DirecTV or your Sirius XM, but it was small. And that workforce essentially just moved between companies and between contracts. A few would retire, a few would join, and it was relatively static. With this prediction of a $1 trillion economy by 2040 and this just explosion we're seeing of commercial space, the workforce absolutely does not exist to support that. So something has to be done. And I think, when we look at college or even what I'm doing and we're focused on at Novaspace, so that training and professional development, those are aspects that are important to supporting that. But the other part that's really necessary is bringing in people from other industries. So, and we kind of butted on this a little bit with the welder, but it comes to everything. You may be a fantastic project manager, or you might be a really great HR recruiter. There's a place for you in the space industry, and so many of them don't realize that exists. But every one of these companies that, especially on the commercial side, they need that entire list of staff of people, and they're not just rocket scientists and astrophysicists and things like that. And so I think part of this is really expanding the aperture on hiring. And so when I look at job positions that are out there, so many of them require a significant amount of experience, a significant amount of education in space, and you're going, these people don't exist. And so what happens is you're just poaching the same people back and forth from companies. They're getting paid more and getting more benefits each time they jump. So it's great for them. But instead of saying, hey, I need somebody with 70% of these requirements and I can train them on the other stuff. I can pull them from other industries and we can make them into space people and we can continue growing them as space people throughout their career. I think that is a significant area that's lacking in how current space is approaching the workforce development.
What other challenges, Joe, do you see to the education of industry personnel? Do you see perhaps that over the next decade or so that kind of training is going to be much more widely accepted?
I think it's going to have to. I don't see how they're going to do it without it. But part of the problem is they never had to before. So right. Previously, like I said, the space industry, they had their people and they used mentorship and on-the-job training methods, which aren't bad. But the problem with mentorship and on-the-job training is it depends so much specifically on that mentor or on that person that's giving the OJT. And the problem is there's a complete lack of standardization to that. That person's personal experiences as they're passing on information to the younger generation is good. It's good and bad. It's great for teaching lessons learned. It's great for personal career development advice and growth and things like that. But if you're teaching, orbital mechanics or, how an optic is designed, let me put it this way. You're not going to teach the foundational stuff across the spectrum using OJT and mentorship. And part of the reason is those people are not educators. That's not their job. They're a scientist. They're an engineer. In fact, you're taking them away from doing their daily job in order to do that stuff. It's better to use them specifically for those lessons learned, that team building, that individual building. Use them for that and use a standardized method across your company for teaching the foundational stuff and then advancing to specialty and advanced topics. That way, everybody is getting the same thing. And I think that is something that, one, really helps build a strong culture within a company of knowledge and experience. But it's a paradigm shift that has to occur because otherwise, if you think you're going to just do it with your internal people, you're both limited by cost and time. That it's not going to happen. It's going to fall by the wayside.
It would seem that for a while, space was kind of a club. There was NASA, there was ESA, there were a couple of the Boeings and such, but it was a pretty small club. Do you feel like now that there's a lot more room in the club, given the kind of explosion of the commercial space industry?
Oh, there absolutely is. I mean, it's changed drastically. I mean, well, once again, you can kind of look at computers and the internet, in the 80s and early 90s, right? There was Apple and IBM. And then, right. There were a few big ones. And then suddenly you start seeing all these other companies coming online competing, which is wonderful, right? Because it drives everybody to advance more, work harder. That competition is wonderful. But the bar has changed significantly. And I think part of it is because, while there are, I'll use launch as an example. Yes, there's SpaceX, there's Blue Origin, there's ULA, there's your traditional launch providers. And there's a slew of new launch providers that are trying to come online, Firefly and Relativity. And, there's a number of them, but that's launch. But when you look at all the things that we're trying to do in space, whether it's building a certain part that's going to be used in a satellite bus, whether it's designing a certain optic, a certain antenna, on-orbit manufacturing, biomedical, we've gotten to the point that it's so broad now that it's kind of like that Internet of Things where the applications are endless that you could try and develop to support our growth in space. So that market is really open wide at this point.
Joe, we're just about out of time, but I want you to take a moment and think out 10 to 15 years in space commerce and tell me what you see.
I think for me, there's three big things that are going to happen with regards to space commerce in the next 10 years. I think data is going to be everything. the amount of sensors, optics, radio antennas, the amount of information being gathered from space is just absolutely extreme, and it's only growing. So how you collect that, analyze it, package it, sell it, make it useful, I think data is going to be huge in that growth. I think energy is going to be really interesting. Small nuclear reactors, improved solar and battery technology, like we were talking about how that affects us then on Earth. I think those are going to be critical aspects that are going to really grow. And I think on-orbit manufacturing is going to really change things as well. Once we can start, and there's really a lot of work on this, when you can start building things in space instead of on Earth, it changes the whole dynamic for launch cost and what you need to bring up, and really allows that growth to accelerate in a huge way.
So those welders may need to learn how to weld in a spacesuit.
I think it's coming.
It is coming. Joe, we're out of time. Thanks so much for taking time to be with me today.
Thank you very much. It was a pleasure to be here, and please visit us at Nova Space.
Absolutely. Joe Horvath is CEO of Nova Space, and that's going to do it for this edition of the Ex Terra Podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, and many other popular podcasting platforms. Be sure to click on subscribe so you don't miss an episode of the podcast or any of our other videos. You can also get daily space commerce news at xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on Twitter at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers, my Galileo through his looking glass. Thirst for reason. A dreamer's eyes we gaze into, a sense of purpose, know my view. Like finding water on the moon.